The learning target is I can find the constant of proportionality from a real-world problem. Constant of proportionality is the constant value of the ratio between two proportional quantities. You can find the COP or the constant the same way that we would find the unit rate. And we're going to use this constant to write equations, and our formula for that is y equals kx, where the only thing we're going to change in this equation is k, which is the constant. So whatever we find as our answer, we're going to substitute in, we're going to take out that k, and we're going to substitute it in our number. So for question number 1, we have a train travels 90 miles in 1.5 hours. Write an equation that represents the number to find the number of miles y per hour x. So we have we want to find miles per hour. That's our per statement. We want miles per hour. Oh, I just was going to write per statement. Miles per hour. We're going to go back into our problem to find the ratio that's given to us. So we have 90 miles in 1.5 hours. I'm writing that ratio as a fraction. And we know if miles is on top, miles has to stay on bottom. If miles has to stay on top. If hours is on bottom, hours has to stay on bottom. And we go back to our per statement, miles per hour, which means we want 1 hour with x miles. So that's what we're looking for. We can cross multiply. Well, 1.5 times x is 1.5x. And 90 times 1 is 90. We know we divide both sides by the coefficient, that number in front of x. And so we're going to say x equals 90 divided by 1.5. Remember, top number divided by bottom number, which is 60. Now, we're going to use this formula to write an equation. So y, our miles, equals, instead of the k, we're going to put in our 60x. And that would be our proportional equation. Question number 2 says Kai can run 3 miles in 27.5 minutes. Write an equation per minute. So our per statement would be miles per minute. We go back into the question to find the ratio that's given to us, which is this one right here, 3 miles. I'm writing it as a fraction, over 27. I'm going to change it to a decimal, 27.5 minutes. I'm going to set up the other half of my proportion. My other ratio we know has to be miles and minutes. The order matters. And our per statement says we want per minute. So we only want 1 minute and x. And then we can solve. So we know 27.5 times x would be 27.5x. And 3 times 1 is 3. We're going to divide by 27.5 on both sides. And we're going to get a very, very, very small decimal of a number, which is going to seem crazy or weird or wrong to us because it's going to be 3 divided by 27.5. I know 27.5 is bigger, but we're solving the proportion as is. So 3 divided by 27.5, which is going to give us 0.109, where the 0.9 is repeating. So I'm going to put that over the 0.9, the repeating mustache. And then I'm going to write it as an equation. So the only thing, again, I'm changing is k. So y equals 0.109x. All I did was I took my value and I placed it in my equation. So what happens if the problem asks us to use different variables? So for example, at Stop and Shop, Brett buys 2 pounds of turkey for a total cost of $10.50. Write an equation for the cost C per pound of turkey T. Well, our per statement is going to be the same, cost per pound, where C is using for the cost and T is for pound of turkey. We can set up, we need to still find the constant, so I'm going to use 2 pounds for $10.50 So I'm going to write 2 pounds over 1050. And we want per pound, so 1 pound over x. And we can solve like normal, so 2x equals 1050, cross multiply, divide by 2. And so x is going to equal, I believe, 5.25, but let me just check my calculator. Yep, 5.25. So normally we would put y equals 5.25x, but they asked us to use c and t. Well, it's easy this way. C equals 5.25 t. We just brought down our cost. Our per is this right here. That's what we solved for. And pound, we used t, so we brought down the t. C equals 5.25 t. If 3 tickets to a show cost $13.20, write an equation to show the relationship between cost C and the price per ticket T. Very similar. So the cost per ticket, the cost we're going to use is C, and the price per ticket we're going to use a T again. So now I can use my ratio. 3 tickets for $13.20. So I'm going to put it over here. 3 tickets for $13.20. And we want per ticket, so we're going to do our 1 ticket over x. When we cross multiply, we're going to get 3x equals 13.20. We're going to divide both sides by 3. And so that's an ugly 20, but 13.20 divided by 3 will give us 4.4. I'm going to add a 0 because it is money. And again, all we have to do is take this and put it in for per. So C equals, don't forget that equal sign because it does have to be an equation, 4.40 T. It costs $15 to ship 3 packages. Write an equation that represents the cost per package. So the cost per package is our per statement. We're going to use a C for cost, and we're going to use a P for package. And back to our proportion, our ratio is $15 to ship 3 packages. And we want per package. So 1 this time is going to go on bottom because I put my packages on bottom, and x on top. 3x equals 15. Divide by 3. So we know x is going to equal 5. So that's going to be my 5 equals cost per package. C equals 5p. And our last one, which is the state test question, it says, the cost of oranges in a grocery store is directly proportional to the number of oranges purchased. If Jerry paid $2.52 for 6 oranges, and P represents the cost in dollars, and N represents the number of oranges purchased, write an equation to best represent the relationship. Well, we need the cost per orange. We want to know what 1 orange is going to cost. Now they used P for cost, so I'm going to put a P. And for oranges or number of oranges, they used an N. I'm just using what my question tells us, P and N. Now the ratio they gave us is $2.52 for 6 oranges. And we want per orange. So our 1's going to go on bottom and our x is going to go on top. So 6x, when we cross multiply, is going to equal 252. Divide by 6 on both sides. And x is going to equal 42 cents. So all we need to change, we know P is the cost. The per package is going to be our answer. Our 0.42, and our number of oranges is going to be N. So here would be our equation. P equals 0.42N.